Imagine that somewhere far above the Earth, beyond satellites and weather balloons and drifting bits of old spacecraft, a tiny object materializes in space. It is no larger than a pebble, no heavier looking than a pocket stone, but it is not a stone. It is a piece of a neutron star, an object so dense, so heavy, so unthinkably compact that a teaspoon of it weighs as much as a mountain. And now, through some impossible accident of physics, that teaspoon-sized fragment begins to fall toward Earth. At first, nothing seems unusual. From the ground, the object is invisible. It doesn't glow, it doesn't burn, it doesn't streak across the sky like a meteor. It simply falls, pulled downward by gravity. But as it approaches the atmosphere, the world begins to notice something strange. Air currents shudder. Birds veer wildly off course. Compasses twitch. Electromagnetic fields ripple like disturbed water. Then the fragment enters the atmosphere and reality breaks for a moment. Instead of slowing down like a normal object, it slices through the air as if the air barely exists at all. The gases above it flatten into a tight, compressed shockwave, but the neutron star fragment doesn't burn. It forces matter out of its way with overwhelming gravity. It slams downward faster, not slower, accelerating like a falling black marble that refuses to care about friction. Long before it hits the ground, the Earth begins to deform beneath it. Gravity is not gentle with neutron star matter. Even a pebble-sized piece has a gravitational pull thousands of times stronger than anything on Earth. As it descends, it drags the planet upward to meet it. Rock stretches, soil rises in a bulge. The crust warps like soft clay being pulled toward a pinprick of infinite weight. When the fragment finally strikes the ground, it does not explode. Instead, the Earth does. The piece plunges downward, ignoring solid matter as if falling through talcum powder. The crust breaks open, a ring of land collapsing inward as the fragment bores a perfect tunnel toward the core. Shockwaves rip through the mantle, not in fiery bursts but in gravitational shudders that ripple outward like invisible earthquakes. The hole left behind is impossibly narrow and clean, a precision wound carved by gravity rather than impact. Around it, everything shakes. Buildings sway and crumble hundreds of kilometers away. Deep underground structures collapse instantly. The shockwave travels through the planet at frightening speed, circling the globe and returning to its origin like a seismic echo. Meanwhile, the neutron star fragment continues falling. It passes through the mantle, then the outer core, then the inner core, all without slowing. It is too dense, too powerful, too relentless for anything to stop it. It reaches the center of the Earth and does the one thing every physicist feared. It begins pulling the core toward itself. Iron and nickel, normally kept molten by pressure and heat, stretch unnaturally toward the descending mass. The core shudders, warps, and shifts off-center. Earth's magnetic field flickers. Auroras burst unpredictably across the sky. Birds migrate in wild spirals. Navigational systems fail worldwide. The molten metal starts spiraling toward the neutron fragment, forming an unstable, swirling droplet of superheated matter around the densest object Earth has ever encountered. And then another problem emerges. The fragment does not stop at the core. Its momentum carries it through and out the other side of the planet, leaving a second narrow hole as it exits somewhere on the opposite side of the world. And now, freed from Earth's core but still under the pull of gravity, it begins to fall back again. Like a cosmic pendulum trapped in a planet-sized clock, the fragment oscillates back and forth through the Earth. Each pass tears more of the core loose, destabilizing the mantle, fracturing continental plates, and sending gravitational fluctuations through cities and oceans. Volcanoes erupt where they never did before. Earthquakes split continents. The oceans slosh with enough force to carve new coastlines. The planet groans under the strain of a new gravitational heart beating where none should exist. Eventually, as the neutron star fragment loses energy to tidal forces and gravitational heating, it settles near the center of the Earth. But by then, the core is no longer a sphere. It is a twisted, stretched mass orbiting a hyperdense nucleus. Earth's rotation falters, its magnetic field collapses, and radiation from space begins seeping through the thinning shield. Over time, the planet cools in strange patterns. Weather systems break down, jet streams stumble. The delicate balance that made Earth habitable begins to fracture. If humanity survives the initial destruction, they now live on a planet that behaves like no known world. Compasses point toward a warped gravitational center, not north. Seasons become erratic. Volcanoes erupt unpredictably. The sky glows with strange auroras that appear and vanish without warning. And all of it, the global chaos, the geological wounds, the magnetic collapse, was caused by an object no bigger than a pebble. And somewhere, deep beneath their feet, at the center of a ruined and trembling Earth, lies the quiet, perfect fragment of a neutron star. Too small to see, too heavy to comprehend, and far too powerful to ever belong on this planet.